Hello, this is Dr. Grande. Welcome to my video on statistics and counseling appraisal. And there's four areas that I'll be covering in this video. I'll be looking at the levels of measurement, the distribution, measures of central tendency, and measures of variability. So we'll start with levels of measurement. So as we're conducting research and we're looking at different variables that we want to collect, it's important to understand how to categorize these in terms of their levels of measurement. And the four levels are nominal, ordinal, interval, and ratio. Nominal is the most basic form, and ratio is the most complex. So as we move up levels, like from nominal to ordinal and ordinal to interval, a certain level of measurement is going to have all the properties of the level below it, plus additional properties. So when we look at nominal, the nominal level describes qualitative rather than quantitative differences in variables. So let's look at, in terms of like breed, let's look at the breed of a dog, right? So if you have a poodle, a beagle, and a German shepherd, those are nominal variables. You can't really put them in any type of rank order. An item can only fit into one category. So really the only thing you can do with nominal data is to count the number of times a certain item appears in a group of scores. So as you move up to ordinal, ordinal has all the same properties as nominal, except in ordinal you can put them in rank order. So imagine a race, and you have three cars in the race, and one finishes first, one finishes second, and one finishes third. That's an ordinal level of measurement. In an ordinal level, you don't know the difference between first and second and third in the example I gave. So you know one car came in first, it could have been 10 minutes ahead of the second car, and the third car could have only been a couple seconds behind the second car. In ordinal, we don't know. We simply know first, second, and third. Oftentimes, Likert scales are thought of as ordinal because the differences between the possible responses, it's not possible to know, or it's difficult to figure out if they're truly equal. So if you've seen a Likert scale and it says strongly disagree, moderately disagree, somewhat disagree, we're not sure if the distance between strongly disagree and moderately disagree is equal to the difference between moderately disagree and somewhat disagree. It's important to recognize, however, that oftentimes Likert scales are treated as interval, so that parametric statistics can be applied to them, so more sophisticated statistics can be applied for analysis. So that brings me to interval. So interval has all, the interval level of measurement has all the characteristics of ordinal, except that there is an equal difference between the scores. Right? So let's look at an instrument that measures, say, depression, and it gives you a raw score. And you have a few scores. You have a score of 50, and a score of 55, and a score of 60. And you know that the 5 points that separate 50 and 55 are equal to the 5 points that separate 50, 5, and 60. So you can rank order them, and the distance between them is equal. Right? That's an interval scale. It's important to recognize, however, that an interval scale has no true zero. And that brings me to ratio. So the ratio scale, the ratio level of measurement, has all the properties of interval and it has a true zero. So examples of the ratio level of measurement would be height and weight, right? So we know that there's an equal distance between the variables and there's a true zero. So there can be 0 pounds, or if you're measuring height, there could be 0 inches. There's a true zero. Now, as you can see, the difference between interval and ratio is fairly subtle, the presence of a true zero. And when you're using SPSS, interval and ratio are both treated as a level of measurement that's referred to as scale. So as you're inputting data, you'll see a nominal level, an ordinal level, and a scale level. That includes both interval and ratio. So now let's take a look at how scores are distributed. I'll be talking about the normal distribution, as well as skewness and kurtosis. So here is a depiction of a normal distribution. So before I get into all the details about the properties of normal distribution, it's important to understand that a lot of characteristics in counseling and in other fields are normally distributed, meaning they follow the same bell curve that you see in this depiction here, which increases the validity and accuracy and the number of statistics that we can use when we're trying to analyze those characteristics, meaning those characteristics that are normally distributed. So on this graph of a normal distribution, the vertical axis would be the frequency, right? The number of times a score was observed, and the horizontal axis would be the scores. So in addition to this representing a normal distribution, it's also called, it's a type of frequency distribution, where you have the frequency on the vertical axis and the scores in the horizontal. That's a frequency distribution. So let's take a look at some of the properties of a normal distribution. The first property is that the mean, the median, and the mode, which are measures of central tendency, which I'll talk about in a few minutes, are equal in a normal distribution. And you can see here at the bottom, I have X bar representing the mean. But of course the mode and the median would also be along that white line. The highest point in distribution is the mean, median, and mode. One other point is that X bar represents the mean in a sample, and mu, the Greek letter mu, represents the mean in the population. Most populations are impossible to measure. Right? They're just too large, there's too many variables to try to measure an entire population. So we measure a sample. So X bar is used with a sample, and the Greek letter mu is used with a population. So of course here, for my example of the normal distribution, I use mu because this theoretically would be a sample. And then you see also along the horizontal axis the -1, the -2, and -3, and then the 1, 2, and 3. Those represent the z-scores. So the 1 is 1 standard deviation above the mean, and then 2 is 2 standard deviations above the mean, and so on. And then the -1 is 1 standard deviation below the mean, and -2, 2 standard deviations below the mean, and so on. You'll notice too in the normal distribution that the 2 halves separated by the mean are identical, and that's referred to as bilateral symmetry. So a normal distribution is bilaterally symmetrical. Also, the tails of a normal distribution are referred to as asymptotic, meaning they approach the horizontal axis, but they never actually touch it. And you notice here I only have from z negative 3 to z3, but actually these scores, the z-scores, would continue on in both directions. But for practical purposes, almost all the time, we'll be working between negative 3 and 3 in terms of appraisal and counseling. Now I'll be discussing standard deviations later in the video, but I want to show you how the scores are distributed in normal distribution in terms of the area under the curve. Right, so if you look at the mean, which is the white line, and you look at one standard deviation away from the mean, you can see that 34.13% of the scores fall in that region, fall in that area under the curve. And another 34.13% fall between the mean and negative 1z. So if you look at one standard deviation each direction, you can see here the green line with the arrows at each end. The 68.26% of the scores fall within one standard deviation of the mean. Similarly, if you move out to the blue lines, that's z negative 2 to z2, 95.44% fall between negative 2 z and a z of 2. And then if you move all the way out to 3 standard deviations below the mean and 3 standard deviations above the mean, 99.72% of the scores will fall under that area of the curve. So again, kind of highlighting why we typically only use from negative 3 to 3, because the vast majority of the scores will be in that area. So now taking a look at skewness. So not every distribution of scores is normally distributed. Matter of fact, it's not unusual to have skewness and kurtosis in a distribution. So skewness indicates the degree to which a distribution of scores is asymmetrical. You can see that these two distributions, this negatively skewed distribution and the one on the bottom, which is positively skewed, look a little bit like a normal distribution, but they have a tail. And if the tail extends to the left, that's a negative skew. The mode will be at the highest point in both types of skewness. The median will be next, and then the mean will be closest to the tail. So in this case, you have the mode to the right, then moving one to the left, the median, and then all the way to the left, the mean. And the positive skew is just the opposite of that. Right? You have the mode here on the left, moving to the right, you have the median, and the mean is closest to the tail. So I think the easiest way to remember this is if the tail points to the left, that's a negative skew. The tail points to the right, it's a positive skew. And just remember that the mode is always at the highest point, and the mean is always closest to the tail. And it shouldn't be too hard then to remember that the median is in between them. Now, kurtosis is different than skewness. Kurtosis indicates the flatness or peakedness of a distribution of scores. So you can see here on the left, this is a platykurtic distribution, and see how flat it is. It's easy to remember if you think of the word plateau, right? Then you have this other distribution where all the scores are grouped very closely to the mean. Right, this is leptocurtic. And I like to remember this by thinking of the word leap, how this distribution is much higher than a normal distribution. So taking a look at the measures of central tendency we use in counseling appraisal, first we'll be taking a look at the mean, or average. The mean is the average value in a distribution, and it applies to only interval and ratio levels of measurement, or an SPSS scale. It's highly influenced by extreme scores. So let me give you an example of that. Say that you administer a test, and you administer a test to 12 people, and 10 of the individuals, let's say the test is from 0 to 100, 10 of the individuals score a value of 25%, and the other 2 individuals receive a score of 100%. The mean is going to be highly influenced by those 2 scores of 100%, and not going to be a great representation of the central tendency in that particular distribution, one where you have 10 scores of 25% and 2 of 100%. So you have to be careful when using the mean to watch out for extreme scores that can influence it. It is, however, the most widely used measure of central tendency, and it's fairly straightforward to calculate. It's equal to the sum of the scores divided by the sample size. So now taking a look at the median. Now the median is the value in the middle of a distribution when the values are ordered from lowest to highest. So that last part I just mentioned is extremely important, because it's not unusual to receive data in a format where they're not ordered from the lowest to the highest. So if you take an unordered data set and you just select the middle value, unless it's from lowest to highest, you're not going to have the median. Now technically, if it was ordered highest to lowest, that would work as well. But it has to be ordered. That's what's important. So if you have an even number of values, what do you do then? Because you don't have a middle value, you simply average the 2 middle values. Now, a median applies to ordinal, interval, and ratio data. So it has a little wider range of application than the mean, and is not as influenced by extreme scores as was the mean. So if you think of the example before, where you have the 12 participants, the median in that data set would be 25, which is a little more representative of what's going on, but as you see, it excludes those high values altogether, which is why typically we look at the mean, median, and mode of any distribution as we're considering the true properties of central tendency in a distribution. So let's take a look now at the mode. The mode is the most frequently occurring value or score in a distribution, and it applies to all the levels of measurement: nominal, ordinal, interval, and ratio. It's useful for large sample sizes. So imagine that you have a relatively small sample size, and you have a range of scores from 0 to 100. Let's say the median is 50 and the mean is 50. But at the low end of your scores, the value 5, right, appears 3 times. And many other values in your distribution appear once or twice, but not 3 times. So the mode would be 5, which would really not, that value of 5 is not a good representation of the central tendency of that distribution. That phenomenon is more likely to happen in a small sample. In large samples, the mode will usually be much closer to the mean and the median. Keep in mind too, there can be more than one mode in a distribution. If it has two modes, it's called a bimodal distribution, and if it has more than two, it's called a multimodal distribution. So now, switching gears a bit, moving to measures of variability. And measures of variability are the degree to which scores differ from the mean. Right? That's what they represent. And there's a few different ways of measuring variability. One is range. And range is the highest score minus the lowest score. So if you have an instrument and it goes from 0 to 100, and the high score is 65 and the low score is 45, the range equals 20. Range is heavily influenced by outliers. And I would recommend not depending on exclusively the range when trying to measure variability in a distribution. Then we have variance. And variance refers to the average amount of variability in a distribution. Now, variance is not usually used by itself as a term when we're talking about results. It's instead frequently used in other calculations. It's an important metric, but we typically see it in equations that are used to calculate other metrics that we use. A good example is the variance is the square of the standard deviation. The standard deviation we use frequently, but the variance we do not. It's important to understand the relationship between standard deviation and variance. So let's take a look at standard deviation. It is the average distance of scores from the mean, and it is the most frequently used measure of variability. Now, as I mentioned before, the variance is the square of the standard deviation. So, of course, that means that the standard deviation is the square root of the variance. So to give you an example of the standard deviation, say that you had an instrument with a mean of 50, and the average distance of the scores from the mean was 10. So the standard deviation was 10. That unit of 10, that difference between 50 and 60, is referred to as one standard deviation. So if you look at 40 to 60, that's one standard deviation in each direction, right? So that's negative 1z, z equals negative 1, to z equals 1. And as you might remember from the slide on normal distribution, 68.26% of the scores would fall between that value of 40 and that value of 60. Now that particular type of distribution where the mean is 50 and a standard deviation of 10 is the same as a t-score, which is a very popular standard score used in appraisal. Oftentimes instruments are converted to a t-score so that they can be compared to one another. So the mean is equal and the standard deviation is equal. Therefore, it allows two completely different instruments to be compared. I want to thank you for watching this video, and I hope you found it helpful. As always, if you have any questions or concerns, feel free to contact me, and I'll be happy to help you.